So now we are asked to factor these different problems here completely. And although this chapter is the perfect squares chapter, where if you see this pattern, then we can go ahead and set it equal to a plus b parentheses squared, or a minus b parentheses squared. We now need to figure out which method is going to be used to factor these polynomials. And what are the steps? The first step would be to factor out the greatest common factor, of course. Sometimes that even solves the problem for you because that's all you have to do to factor. Second step would be to check for the difference of squares or a perfect trinomial pattern. And that's here. It's a squared. Difference of squares is a squared minus b squared is equal to this expression here. The perfect squares trinomial is this one here or this one here, in which case our answer or our factors would be the sum of a and b squared and the difference of a and b squared. And if it doesn't fit these two patterns, then we can apply the factoring patterns for x squared plus bx plus c equals 0, right, to factor using the x method. Or we can look for the ax squared plus bx plus c equals 0 pattern, in which case we would use the x method with that slight adjustment to factor the polynomial. And then the fourth possibility is factoring by grouping if we have four terms. And yep, that's how we want to go through them. These are all the different methods that we learned how to factor. Factor out greatest common factor, difference of squares, perfect square trinomial, a factor by using these two patterns, and also a factor by grouping. So when we're looking at this here, we want to see if we can factor out a greatest common factor. That's step one. And we can. There's a 2. And so 2 is the greatest common factor. So we'll say 2 parentheses x squared minus 16 parentheses. Now we're looking at the polynomial in the parentheses, and we're checking to see if it fits any of the additional patterns. Difference of squares. Yes, it does, right? Because x squared is a perfect square and 16 is a perfect square. So we could say a squared is equal to x squared, and we could say b squared is equal to 16. Now we need to figure out what a and b are, so we're going to take the square root of both sides, and we'll say a is equal to x, square root of that side, and we'll say b is equal to 4. And then we can go ahead and write out our factors, right, using this pattern right here, because it's a squared minus b squared. We figured out what a and b are, and we could just go ahead and stick it into the template there, which will give us our factors. So starting with 2, it'd be 2 parentheses a plus b, so it's x plus 4, parentheses x minus 4. All right, so that one's done. Looking at this next one over here, can we start with step number 1, factor out any of the greatest common factors? Yes, there's a 5. Oh, no, we cannot because of the 12. So let's see, 3, 4, nope. So nothing else. There's no greatest common factor, so we're going to skip that step. And then we're going to look for difference of squares. That is this here. No, it does not fit that model. And then over here, does it fit the perfect square trinomial? And it does not look like it does, right? So we have a squared. So this is not a perfect square. This is a perfect square. So this number here is not a perfect square, 12. So it doesn't fit the perfect square trinomial because a needs to be a perfect square and b needs to be a perfect square in order for that to work. So then we're looking down at the next pattern. It's this one here or this one there, where the coefficient in front of the x squared is a number. So this is ax squared plus bx plus c, and here we can factor out using that pattern, right? So the first step here would be to put it in standard form. It is in standard form. Factor out any common factors. Greatest common factor, there is none. The next step is to identify a, b, and c. So a is equal to 12, b is equal to 5, and c is equal to negative 25. Now we're going to make our x. We'll put our a times b, a times c up here at the top. So 12 times negative 25. What is that? Let's see. 12 times 25 is going to be negative 300. So I'll say negative 300 there, and we'll put b at the bottom of a 5. We have our a, so it's going to be 12x on the top of that fraction there, and 12x on the top of that one. Now we need to figure out what are the factors that go underneath that multiply to negative 300 and add to 5. So we start with 1, which it obviously is not going to be, so it's 1 times 300. It's going to be, what is it? 2 times. Now this method will take a very long time, right? Starting at number 1 and then going 2 times 150 and so on. I think I found it. I think it is. No, it's not. I thought I had it in my head. Okay, let's go ahead and keep going. So we have 3 times 100. Is 4 a factor of 300? Let's see. Yes, 4 times 75. But that doesn't work. And then we have 5. So 5 times 60. That doesn't work. 6 does go. It's 6 times 50. That doesn't work. Then we have 7. I don't believe 7 is a factor of 300. No, it's not. So what about 8? I don't believe 8 is a factor of. Nope, it's not. 9 is not a factor. 10. So we got 10 times 30. 10 times 30. That doesn't work. Then we have 11. 11 is not a factor. 12. I don't believe 12 is a factor. Yes, it is. 12 times 25. 12 times 25. Okay, that doesn't work. Now 13 does not go into 300. 14 does not go into 300. 15 does. So we have 15 times 20. Oh, look, we found it. Finally, it's 15 times 20 because they will subtract to 5. So we'll put 15 over here. We'll put 20 over here. One of them needs to be negative, and so because our answer is positive, that means our smaller number is going to be negative. Negative 15 and positive 20. Now we need to reduce our fraction. So it's going to be a greatest common factor of 3. So it's going to be 4x over negative 5. And then this one over here, greatest common factor, I think would be 4. So 4 would turn into 3x over 5. Okay. So now we have our two factors. We can go ahead and write them out. It's 4x minus 5 and 3x plus 5. Like so. All right. So anyhow, how do we solve these? You need to go through the steps one at a time. Factor out the greatest common factors. Check for difference of squares. Check for perfect square polynomial. Apply these two techniques, and if that doesn't work and there's 4 terms, we factor by grouping.